Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are still going to talk about complex numbers and basically their use in quantum computing and simply their use in general. So since this is an introduction course, basically I'm not gonna talk about all the mathematical concepts and make all the mathematical proofs because some of you guys simply don't have the mathematical basics for all this. So my goal here is really to present you complex numbers and explain you complex numbers as for beginners. All right, so basically we talked about complex numbers in the past class, and what we'll do today is really understand why they're used and what exactly are the properties of those numbers. All right, so basically where exactly complex numbers are used. So there are plenty of fields where we can use complex numbers, but it's not really used in operations, well, in everyday operations. So let's say, for example, you guys are going to a store. The person who will serve you, or even you when you are buying something, you will not use complex numbers to calculate, I don't know, how much apples you are going to buy or how much it's gonna cost you at the end. So basically you will make normal calculations. But complex numbers have utilities in more advanced calculations. So basically in advanced physics, in advanced mathematics, they're really present, and this is where they are used. So basically some examples of fields where they are used, well, it can be used in many fields such as electricity, for example. It could be used in mechanics, it could be used in engineering, or even in quadratic operations, well, equations, sorry. And when we're working with a quadratic plane, those numbers will simply never touch the x-axis. So what does this mean? So let's say, for example, we have a complex number that is a equals to 5 plus I. In this case, let's say 5 plus I, well, our 5 plus I will be our complex number. So basically in this number, the real part will be the 5. So basically 5 is a real number, and the complex number will be 1 multiplied by I. So in this graph, when you are drawing the graph of 5 plus I, what we'll see is that the x will be 5 and the y will be 1, because basically the y represents all the imaginary numbers, and the x will simply represent the real numbers. So in this case, the x could never be 0, and why? It's pretty simple, because if it's equal to 0, our imaginary number will simply not exist, because everything that you will multiply by 0 will be equal to 0. So basically this will make our complex number disappear, and we will only have one real number. So basically it's not a complex number anymore. So this is why it will never have x equals to 0 as a complex number. And also they are really useful in more advanced calculations. So basically, as I said at the beginning, when you are working with more advanced calculations, especially in physics and all this stuff, they're really useful. So why are complex numbers used in quantum computing? So basically, the main purpose of using complex numbers, especially in quantum computing, is to make your operations way more simpler. In other words, when you're working quantum computing, but not only in quantum computing, but in mathematics in general, when you are going to more advanced mathematics or more advanced physics, what's going to happen is that you will have very heavy operations. So let's say you will have really big operations, and to be able to work properly with those operations, you'll need to simplify them. And the best way to simplify those operations, or simply to simplify very heavy concepts, will be the use of complex numbers. And basically those complex numbers help us make those operations way more easier. So an example of something that is really used in, for example, advanced mathematics, or advanced mathematics, more the algebra part, or advanced physics, will be linear algebra. So basically it's really used in quantum computing. This part will be heavily simplified with the use of complex numbers, because it will allow us to make heavy operations way more smaller, and in this case make them way more easier to work with. So this is why complex numbers could be really useful, especially, well, in more advanced fields. All right, now let's talk about the properties of complex numbers. So in this case, complex numbers have three main properties. So they can be commutative, they could be associative, and they could be distributive. So it's not really hard to understand, but I think it's really important to understand it as well. So for the commutative part, what exactly this means, it's pretty simple. That means that changing the order of the operation will not change the result at the end. So let's say we have the same complex number that we had before. So our complex number is a equals to I plus 5. So in this case, I plus 5 would be our complex number. If instead of I plus 5, we have 5 plus I, changing the order inside of the operation will not affect the complex number at the end. So simply changing the order of one number to in front of another number will leave us with the same complex number at the end. So basically, this is the first property of our of the properties of complex numbers. The second one would be associative. So basically, a complex number is associative, and that means that we can group the terms how we want. It will not change the results. It's pretty well, it looks like the first one, so it's a bit like being commutative, but it's a bit different because instead of working with just one number, instead of changing like one number of places, we are talking about a group of numbers. So let's say, for example, we have our complex number, which would be I plus 5 plus I plus 7. So right now we have four numbers. The first group will be I plus 5 and the second group will be I plus 7. So in this case, changing places I plus 7 with I plus 5 will simply not affect the complex number at the end. So basically, if we write down I plus 7 plus I plus 5, it's the same thing as writing down I plus 5 plus I plus 7. So this is another property of complex numbers. Changing terms inside, changing group terms inside of the equation of the complex number will not affect the complex number in the end. And finally, the last part is a complex number is distributive. In other words, what's gonna happen is that it respects the property of operations. So what we need to understand here is that, for example, a multiplication will go over an addition, for example, or a division will go over an addition again. So let's say we have a complex number a once again, and it's gonna be 2 multiplied by I plus 5. So let's put I plus 5 in parentheses. So what's gonna happen is that the parentheses are respected and the multiplication will be respected as well. So finally, a will be simply equal to 2 multiplied by I plus 2 multiplied by 5. So as you can see, the property of operations is respected, the parentheses are respected, and everything is, works perfectly, and all the properties of operations are respected as well. So to summarize everything, what we talked about in this class, we simply talked about the properties of complex numbers and where they can be used. Where exactly complex numbers are used and why they are used in those fields. So as I said, I will not go too much in depth in these concepts because the more I go in depth, the more it's going to be hard to understand. But just for you guys to understand that they exist and they are really, really used, especially in quantum physics, quantum computing, as well as in advanced mathematics, in mechanics, physical mechanics, quantum mechanics, and some other really advanced mathematic fields. So that's it for this class, guys, and see you all in our next class.